Good evening, everyone. So I'm Engineer Murtali Shahid, Chairman of IT and Computer Engineering Section Committee. Thank you for being here with us today. On behalf of IT and Computer Engineering Section Committee, I'm pleased to welcome all of you all today for the session on securing Kubernetes, best practices and effective strategies. So without taking your time, I would like to introduce our speaker for the session today. Uh, Nilesh is a principal platform architect at Insighter. Nilesh is a authorized Google Cloud trainer, a Google Cloud certified professional cloud architect, and a certified Kubernetes administrator. Nilesh has been in the industry for more than 9 years. He is the Kubernetes lead of Kubernetes Sri Lanka community and is a public speaker for the technologies around cloud, Docker, Kubernetes, microservices, and related frameworks. I would like to highlight one thing about Nilesh. He was participated as a speaker for the under the topic of security in the recent Kubernetes Community Day held in Chennai in last July. So he was as a speaker. He was invited to Chennai to give a speech on the Kubernetes Community Day 2023. So with so please drop your questions in the chat box and we'll be answer that question as soon as possible or at the end of the session. Okay. So once again, thank you very much, and let's start our session. So Nilesh, over to you.
Yeah, thank you, Mutali. So as he said, I did this a month ago in Chennai, the same slide deck. I think the advantage here is you can ask me any question after the slide deck, and you can have a conversation here in this session. So to start with, so as I said, I'm Nilesh and I'm an architect at Insight, and what I'm doing is I'm actually building DevOps automation platforms so that developers can focus on code and you know and have enterprises to enforce their policies and get them going really fast rather than slow down the processes with platform engineering processes and all of the others, right? So one of these things is securing Kubernetes, and I've been working with Kubernetes for about around 6 years now. And all of this is like sort of like a collection of my experience and a bunch of advices that I have to give to you if you run Kubernetes. Okay. So if you look at the attack surface of Kubernetes, as you can see from this slide, there are a few areas. One, the biggest area is the cluster, but inside the cluster, we have something called the control plane. And if you know, like a lot of people, like if you have managed Kubernetes with EKS, AKS, GKE, etc. And in order for you to sort of like do CI/CD, let's say you're going to do CI/CD with GitHub Actions. You'll expose this Kubernetes control plane API, Kubernetes API through the API proxy as a public IP address so that, the GitHub Actions or whatever can reach it to deploy. I've seen it commonly among multiple startups, many companies doing that, unaware of the risks of exposing your Kubernetes control plane to the public. That's the first access point for your Kubernetes cluster. The control plane components in your cluster, like you can have etcd and few other things, and all of these have APIs. And if you don't have proper firewall setup, those ports can be accessed, and people can exploit them and gain information through those. The next one is the Kube API server, which I just spoke about. If this is openly exposed and if there's a vulnerability or something, people can easily exploit this and attack your cluster. Then we have something called kubelet in Kubernetes. So every node in Kubernetes, the bulk of the action is done via the kubelet. So each node would run kubelet, and this is the part where they maintain your containers, manage their the container lifecycle, and do all of those things. So this kubelet is getting exposed via a port called 10.0.25 or something. I can't remember exact port. But if people can access this, if this is exposed outside, and if people can ping this port, they can do quite a lot with your attack your node and do quite a lot. And the last one is the actual application, sorry, actual application that you run. So if you don't follow proper developer guidelines and proper developer practices, your container could be exploited, and through that people can gain access to the node. Through the node, people can gain access to the kubelet and then kube API server and then attack the entire thing, right? So this is the sort of like the attack surface Kubernetes has. So if you have any questions, just drop. I'm not actively looking at the chat messages. So if there's anything, just Mutali or someone, you can just pause me and ask the questions.
Yeah, sure.
Okay. Right. So let's go with how to protect your application runtime. So this is basically how a normal pipeline, CI/CD pipeline should be. So in many organizations, I think we are past the days where we would copy paste code into the server. So many organizations and established enterprises have some sort of a CI/CD pipeline, and many use Jenkins, and then I've seen quite a lot of people use GitHub Actions or GitLab runners, and some people use Circle CIO, other paid tools as well. So let's look at stages of our CI/CD pipeline. Obviously there's the source code, and then the next stage would be somebody is going to do a commit or a PR or something to the source code, and you're going to do a merge, and through that you're going to trigger a pipeline. So the first step obviously is going to be the build step. So with that build step, you would be generating artifacts, you'd be generating images, container images, and then you'd be testing them, and then you'd be deploying them. So this is like a generic flow of how your CI/CD pipeline should be. And so vulnerability testing. So these are the security layers that needs to be applied to your pipeline stages. So vulnerability testing has to be added on all four stages. Like for example, how do you test vulnerability on source? Easy. Use SonarQube or something similar, so that you can actually scan for vulnerable code, in the sense you can check for vulnerable packages that you've been using. You can check for whether you have hard-coded credentials to your code and all of that. At the build stage, again, the image that you generate. So if when you do a build a Docker container, there are multiple ways you can do. So if you haven't used proper guidelines and haven't used proper practices, there's a chance your image could have vulnerable libraries, or certain vulnerabilities that other people can exploit. So you can get that sorted out. And then testing, of course, when you do your contract testing and whatnot, you can do vulnerability testing there as well. And finally deploying. So when you deploy to the Kubernetes cluster, at the end of the day, it's a bunch of YAMLs or configurations. So you have to test those configurations as well against, I'll talk about the tools. You can test them against a certain tool and check whether they comply with your policies, and do all of that. So as I said, vulnerability testing spans across all four. Then we have something called static security testing. So static security testing is basically what I told you currently, like check whether your code is, code have, hard-coded credentials, or whether your image has baked in environment variables, stuff like that, which are static, and you can scan and, get a report and get an idea. And then the next one is runtime security, which only applies at the deploy time or at the running time. where your application is running, and then you need to sort of like check whether your application is doing what it's supposed to do, whether there's like, let's say somebody has hacked into your container and doing some unwanted shell commands, or trying to escape into the VM. So having a runtime security tool and analyzing those things could help you quite a lot to prevent those things, and get alerted and do all of it. Otherwise, we won't even know if somebody has accessed it, escaped into into the virtual machine, and then done something bad and has gone, and we have no idea about it. Final one is auditing and monitoring. This also spans across all four. For source code, of course, auditing is basically the PR review process that you have as developers. So every code that you merge, you don't blindly merge it, you go through a PR approval. So it's basically the developer discipline. Builds and test, all the reports and everything, you can save them and you can store them. Deploy also the same thing. When you do scanning and all of it, you can store them, the reports and all of it, and you can analyze them later as well. So these are the security layers and how they impact with pipeline stages. I'll take a pause here to see whether there are any questions. Are there any questions? Yes, not. Okay, no questions. We'll move on. How does static security testing work? If you look at the image here, it's a very basic one. We have Ubuntu, which is it's green because it doesn't have any vulnerabilities. But then you use the Apache 2.4, which is built on top of Ubuntu layer, which has vulnerabilities. And then you are using a WordPress image or a PHP 7 image, official Docker Hub, right? So because it is, generated through, like, it's built on top of Apache 2.4, those vulnerabilities, are there on the final images as well. So you have to create normally find images without any vulnerabilities. Normally, the Alpine images don't contain vulnerabilities, but if you go with Jesse or other Ubuntu or other flavors of official images, they tend to have vulnerabilities because they have much more libraries than the Alpine image. But normally the Alpine image is quite good for any language, the official Alpine image for any language. They wouldn't have much vulnerabilities, like no critical vulnerabilities, but there could be major or minor vulnerabilities. So what would happen if somebody exploits your application through these vulnerabilities? So one thing is, privilege escalation. So somebody can escape your container into the VM, because how Kubernetes or anything works with containers is basically you have a virtual machine. In that virtual machine, you have these containers. So in a multi-tenant scenario specifically, if somebody accesses your container and exploits your container, they can actually escape your container and then attack the other tenants' containers as well. It's quite dangerous. The next one is remote shell access. Of course, if they exploit it, they can get a reverse shell, and through that, what they can do is they can do Bitcoin mining. They can do anything basically once they get the shell access. And also they can leak information, like if they print environment variables, and if you have your database credentials as environment variables, they can quite easily see it, and then they can attack your database and then gain access and all of that, change stuff, do all of that. DDoS, it's quite obvious, you can do DDoS with it. To avoid this, what we can do is like use tools like Clear or Trivi. There's another one called Snike by Docker. Use this to scan your images and check whether there are any vulnerabilities or not. And there are scenarios, right? You're using this image, and then even we have, I think, my personal experience, there have been critical vulnerabilities in which we don't have a solution for those. So couple of things you can do. One thing is actually evaluate that vulnerability and talk to your risk assessment or security team and create a GitHub issue or whatever, and then ignore that vulnerability till you find a fix, right? Don't just blindly ignore it. Just log it somewhere as a GitHub issue or whatever, and then uh, move on with your work. Otherwise, you will probably have to either change the libraries that you have used or do the hard way, write that functionality yourself or find a different library, do stuff like that. There have been scenarios where we've cloned certain libraries to fix these issues, and then the PRs were not accepted, and then we had to use the private cloned, the forked version as the library with the security fixes. So things like that normally happen. And another thing I just wanted to point out is, let's say that you scan your images today and there are no vulnerabilities. And let's say you're not doing any deployment for the next year for this particular microservice. Within that time span, the libraries that you already had could have vulnerabilities that have been discovered. So it's a good thing. Like if it's a continuously moving project, it's okay. But if it's like, if you have done and dusted and you're not going to do any development for a certain project, it's advisable for you to run at least a static scan every month or so, so that if there are any newfound uh, issues, vulnerabilities, you can find it. Because the recent example is Log4j. For years, Log4j was used and nobody knew the vulnerability, and then Log4j vulnerability came out, and then a lot of servers got attacked. So yeah.
We have a question. When we are using some images like DigitalOcean droplets, when we are delivering an application, sometimes I found that there are some SSH naughty logs in the that some servers that will be an vulnerability attack. Yeah. Like that.
So droplets, you are giving the image for the droplet?
Yes.
Okay. And this was scanned via DigitalOcean, or did you scan it manually?
Not scanning, but I check the logs. Like this situation, you are pointing out this thing here. So I have I thought that the according to this diagram, it will be like this attack or vulnerability.
So this is SSH naughty logs, right? Like someone's trying to access your VM sort of a thing.
Yes, sir.
Okay.
Using a phishing attack or other thing because of some vulnerabilities in the images or not.
Yeah, I don't think it's a vulnerability with the image. So like and I think when you spin up DigitalOcean through an image, I think that image is different to a content. I'm not sure. Different to a content image. Could be the same. I don't know what DigitalOcean uses as a template. But
we'll continue the session, and at the end of the session we can answer his questions.
sure. Okay. So we'll pause that, and then yeah, okay. Right. So next one is code vulnerability scanning. And I already explained it in the previous slide as well, the log4j thing, and scanning for dependencies and vulnerable, fixing those vulnerabilities using that. And then the final one is configuration scanning. So there are a bunch of tools for this, like Chekhov, Conftest, CubeSec, etc. So what it does is you can have, like, for example, if you use CubeSec, you can just give your Kubernetes YAML to CubeSec, and it would give you some recommendations. Like, for example, let's say you haven't set up security policies, or you haven't disabled privilege escalation, stuff like that, basic pointers it will give to you. And on top of that, using these tools, you can have company policies, sort of like it's necessary for you to, like, a company policy can have, like, let's say all the containers that run on Kubernetes should be using the UID above 10,000, stuff like that. So you can have multiple policies enforced using this. And this will, at the configuration level, at the platform engineering level, these things can be identified and stopped before they get deployed into the cluster. Let me just quickly walk you through some concepts in Kubernetes. So Kubernetes has this thing called an admission controller. So what it does is basically the Kubernetes has 3 layers when you send a request, like kubectl apply f or kubectl create deployment. What happens is it first goes to the authentication layer and figures out who you are, who's sending the request. And then it goes to the authorization layer where it determines what you can do, whether you can create a deployment or not. And then there's an additional layer called admission control, which can be we can actually edit and change and add policies. So basically, there are 2 admission controls, one being validating webhook and another one being mutating webhook. So I'll speak about validating webhook. So this is basically a read-only hook. So when I say kubectl apply f some deployment, validating deployment is going to read that deployment spec, and then it's going to validate it against some logic that we have given to it. And then it's going to do a allow or request, allow or deny response. If it's allowed, it would go through and get applied. Otherwise, it will get rejected, right? Mutating webhook is different. If you have worked with Kubernetes, there are times where you have to add certain annotations to deployments or services, etc., to get added functionality. So what mutating webhook basically does is when you send the request, it would read these annotations and it would change the payload dynamically using that. There's no validation happening. It's just, changing your payload on the go. Validating is where, we apply policies. So with this functionality, there are third-party tools called Open Policy Agent, and there was another one called Kivro, which would enable us to create company-wide policies. For example, we can create a policy saying you can only run images coming from the company image registry. You can't deploy images from Docker Hub, or you can't deploy images from some public registry, but only your company's image registry, only those things are whitelisted. So you can add policies like that. I think which is quite useful for enterprises. That's how Kubernetes admission controller works. All right. So the next thing we have to do is harden the container. So we spoke about scanning our code, figuring out if there are any issues with the image that we built and all of it. Let's say the image is already built and there's nothing much you can do. There are other things we can do to sort of like harden the container when we build the image. One thing to do is remove bash or shell, but be mindful that if you do remove bash or sh, you won't be even able to exec into the pod because there's no shell for you to attach to. But it's sort of like the ultimate thing where you can remove the bash, and it's very good. Like if you try, like if you have run Kubernetes locally, and if you have tried to exec into Kubernetes control plane components like the kube API or kube controller manage, etc., you won't be able to exec it into it because they have removed the bash in it. Nobody can exec into Kubernetes control plane components. The other one is making the file system read-only. So by doing so, making the root file system read-only, if somebody do exec into your container and exploit it, still they won't be able to install any libraries or anything because the file system is read-only. They cannot write into it. And also make the user an unroot user, so they can't do privileged stuff in it. This can be done. These can be done at Docker image creation level when you write the Docker file. If you can't do it at the Docker file level, you can actually enforce this at Kubernetes level as well. In order to do this at the Kubernetes level, what you can do is, in Kubernetes, we have something called a startup probe. It's similar to liveness probe and readiness probe. You can run a shell command at startup in your container before the main command. So you can actually do a startup probe and you can remove bash using that. And then to make the file system read-only, Kubernetes has something called security contexts. So within security context, you can actually quite easily make the root file system read-only, and then you can set up the user ID, the group ID, all of that, and make privilege escalation false and do all of that. And the third one is enforcing these roles through something called open policy agent and gatekeeper. So what these tools would do, open policy agent or OPA, or even another one called Kivro, what they would do is, like, you can define these policies and make sure that no YAML is going to go into the cluster without these configurations. So it would enforce that. It won't automatically create these settings for you. You have to create it, but it would validate and say if those settings or configurations are not there, it won't allow you to deploy into the cluster. Sort of like a validating thing, a policy management. So that's how you harden your containers. Right. Next one is runtime security. Now, let's say we've done all of these things. We've done the static scanning. We have done the all of these things. And now we have deployed our container into the cluster. This is how containers work in a cluster normally. There's physical hardware. This is a VM. So in the VM, we have something called the Linux kernel, and the Linux kernel has the namespaces, C groups, and all of these things. And on top of it, we have something called the Linux container LXC, which is sort of like the management layer of containers. And then on top of that, we have containers. So the basic of a container basically is, container is basically a collection of namespace and C groups, right? So these two together is what forms a container, a logical thing where your processes are running. So all the things that these containers do are coming into the same Linux kernel, which essentially means that this person can actually, if they escape or exploit a Linux kernel vulnerability, they can attack the other containers as well. This is quite important if you are running multi-tenant systems. Like if you look at Google Cloud, AWS, etc., they're still giving you VMs, right? They don't give you containers as a thing. You can't create, but there are ECS, Lambda, etc. But what they do is they are using this concept called container sandboxing. So I'll get to that. But the idea being here is that just running a simple container doesn't give you the isolation or the security, because these things can be easily exploited, and then other containers can get attacked, especially in a multi-tenanted system. So to prevent this, we have to do something called runtime security. One way of doing it is, the first thing is disabling privilege escalation. But there are scenarios where you might have to run privileged containers. It depends on your requirement. For example, if you are using Kubernetes to do CI/CD, right? If you are doing builds within Kubernetes, that means you have to use a concept called Docker in Docker. Maybe you have to expose the Docker running on the host machine into the container so that it can do the build. So there are scenarios like that. So it's completely up to you and your risk assessment or security team to evaluate those things and do. But there are scenarios where you have to run privileged containers. Then the other one is you can drop capabilities. So there are things called capabilities where Linux capabilities like netrow, and there are a few other things. You can drop all of those support so that the container runs isolated and doesn't have much access to the Linux kernel. Then there's two things called AppArmor, I think comes with Ubuntu, seccomp, I think with SE Linux. Use these profiles to restrict processors running in the container. So what these do is basically the syscalls that these containers do, it would sort of like whitelist those syscalls, and it would only allow those syscalls to run. So basically, if we have implemented this properly, and if somebody else hacks into the container and tries to do something bad, something that container doesn't normally do, which is not listed in the syscalls in AppArm or seccomp profiles, it won't be allowed to do that. That's one thing to do. And there's another one called container sandboxing. This requires you to give more resources, but what it does is it completely isolates, like gives a armor around containers. It's basically a sandbox. So there are a bunch of sandboxes like gvisor from Google, Firecracker from AWS, etc. So if you must know, like Google App Engine is using gvisor, and the AWS Lambda is using Firecracker. And there are other things like Kata container, etc., which does the same thing. I think Azure uses Kata containers. So yeah, and then there are other tools like Sysdig Falco. If you are doing the Kubernetes security exam, you'll have to learn about Sysdig Falco. It's basically a runtime monitoring tool, which basically analyzes all the syscalls that these containers are making, and it would, if there's anything out of the ordinary, it would just alert you and give you sort of like a heads up, like, hey, this is happening, take a look at it. So that's the summary about container runtime security. Right. The final one is like, let's say somebody does get into your containers, and now we discussed that if they get into it. From the previous conversation, we made sure that people can't do anything much if they do exploit and get into your container, but still they can get access information. For example, if you are using environment variables, for example, they can simply print out env and get all the environment variables your application is using, and then use a curl command or wget or whatever, and then attack your database and do stuff, right? So one of the things you have to do is use a secret manager, like inject your data to your containers through a secret manager like HashiCorp Vault, which is open source, or in AWS, Azure, etc. We have Azure KV, AWS Secret Manager, Google Secret Manager, etc. And mount secrets as files. Don't mount them as environment variables, mount them as files. Because when you do mount them as files, of course, if somebody do get into your container, they obviously have to search for that config file. But if they don't know, it's going to be hard for them to sort of like find where it is. But if it's an environment variable, it's quite easy for them to capture it and get it going. So that's why you mount them as files. And finally, when you do logs, don't log sensitive information. Let's say you are trying to connect to Postgres. If Postgres is throwing an error, don't log the password in the log. Or if you're going to do an API call with authorization, don't log the access token. So stuff like that. Be mindful. Those are developer discipline stuff, which you will have to do it on your own. But there are other ways you can actually filter these out, like through FluentD or FluentBit configurations. But still, it's better stop at the developer discipline level rather than going deep into FluentD or FluentBit and go into the log aggregation stuff. Right. Next thing we can do is, if somebody has now access exploited into your container. If you have used namespaces and if you have used proper isolation tools, what happens is the exploitation is only limited to that particular namespace and not to other namespaces. So you can do that quite easily with network policies. It's the Kubernetes equivalent for firewalls. So in Kubernetes, you can create network policies, and then you can say which container which pod can access which pod, and give all of that access. So that way, let's say there's a front-facing front end, and there's a backend API and a database. So let's say, and then and we only give access to front end can talk to the backend, and backend can talk to the database. So in that fashion, if somebody exploits and get into the front end container, they will have to exploit and get into the backend container in order to attack the database. From the front end, they cannot attack the database. So stuff like that makes sense when you actually do network policies and do that. I think I have another slide explaining how network policies work. And the other thing is, even inter-service communication, make sure to make them go through an API gateway. It's quite easy rather than go service-to-service communication, pod-to-pod communication within Kubernetes. It's recommended that you do it via an API gateway and have access controls and all of that go through that. It's just a recommended practice, but of course, some people do tend to do the service-to-service communication within Kubernetes, avoiding the API gateway. Then there's another one called MTLS, which is called mutual TLS. Basically, the person who's calling the person who's calling, like the microservice A and microservice B, if they're both of them are talking to each other, both of them has to validate who they are with mutual TLS, and the entire transport layer is going to be HTTPS, which essentially means that even if somebody hacks into your network or goes into the VM layer or something like that, they cannot listen in to the payloads that are going in because it's encrypted. Yeah, these policies can be enforced via, as I said earlier, open policy agent and Keyvano. So this is how network policies work. So as you can see, we can, in the namespace, we can have ingress all allow policy to the web server. And then web server cannot access the database, only the Python backend can. Python backend can access the database. And then we can have a super important namespace also in the same cluster with an API. And this one cannot reach it at all. So if it's exploited, only this one is exploited. And if they have to do more work to exploit this one in order to attack this, but even if all three are infected, they cannot, reach this one. So that's what network policies do. So that's it about protecting or like hardening your microservices. So let's talk about the infra level, what you can do at a cluster level. The first one obviously being you can add RBAC policies to your cluster, can create accounts, certificates, role binding, and all of it. I've seen in many companies, I'm not going to do names here, they have a single Kubernetes kube config, which they share across with all the developers who can easily log into the cluster. But the problem is all of them are using the same login. If somebody do something bad, we don't know who did what. It's bad. We can easily create accounts and do things. If it's managed Kubernetes, you can it's done by your cloud provider. But if you're using Ranch or something, there are tools that enable you to connect your AD and do that. The next one is enabling audit logging. So as I said, if something goes wrong, only we look at how things went wrong. And if audit logs are not enabled, you don't know who did what. So it's important that you enable audit logging. I think in cloud managed Kubernetes, it's automatically enabled. Else, I think there's an option to enable it. If you are spinning up through Ranch or something, I think you have to, there's also a config. It's not by default enabled. You have to enable it through something and then sync it to some central log management and manage it properly. And then there's CIS benchmark. I think Kubebench, you can run it to your local ones, locally created clusters. But I think the cloud created ones, there's nothing much you can do because the control plane is managed for you. And then using CIS hardened node images. So even in the cloud, if you're running super important stuff, let's say you're running a payment gateway or something, that requires, certain policies and, certain things, it's recommended for you. You can easily use a CIS hardened image rather than use the default image that cloud provides to create your Kubernetes clusters. The other one is, this is specifically if you're running locally, like you're managing your Kubernetes clusters in data centers. HCD should be encrypted. Data at rest should be encrypted, because otherwise anyone can actually look at the HCD file and figure out what the secrets and all of it are. And I already spoke about mounting your secrets as files and not as environment variables, and why that is. Right. Small lesson on RBAC. So Kubernetes doesn't have like a resource called users. So what it has is basically you can actually create a key value, certificate key pair, and then validate Kubernetes to sort of like authorize that certificate key pair. Usually, if we are using humans, like if you are giving access to humans, usually that key pair, like each human should create an SSH key pair or certificate key pair, and then validate it. Somebody who has access to Kubernetes cluster has to validate it, and then you will have access to whatever the roles and permissions that you are given. And then service account is basically for processes, like when you're running certain containers or certain pods that does talk to the Kubernetes API and stuff like that. That's where service accounts come into play. And how permissions work is, Kubernetes has something called roles and role bindings. And normally a role is namespace bound, and a role binding is also namespace bound. And then we have something called cluster role, in which what happens is, if you provide cluster role to a certain user or a service account, they can access all, they have the permission across all namespaces. So far, I have not seen a way we can actually filter namespaces and give at a cluster role level. You get all the namespace support, but there are probably third-party tools that do enable you to give only a bunch of namespaces access via cluster role, and cluster role binding also same. And the important thing here is, you can have an admin role as a cluster role, and if you do a role binding to a user, it will be namespace bound. But if you do a cluster role binding, it will be a cluster wide thing. So that's Kubernetes RBAC. And this is sort of like a small example. I think I'm nearing the end of my slides. So there's John, and there's a role saying read secrets. So this one is binded to John, saying read secret binding to John, and they can read secrets from this namespace. And also there's another role called read write secret cluster role. So this is binded to this admin, which essentially means this admin can write and read secrets across all the namespaces, which is obvious because it's a cluster role. But this one, if I do read write secret role binding instead of a cluster role binding to Jane can only read secrets, read and write through this namespace, and Jane cannot access the other namespaces. That's what it is. So that's a simple demonstration of Kubernetes RBAC. Yeah, as I said, it's a final slide, I think. So as closing thoughts, Kubernetes is still, it's not new anymore. A lot of people are doing it, but still a lot of vulnerabilities get patched frequently and get discovered, and quite a lot of things happen in that space. And one of the major issues is like a lot of our security teams, etc. They are good in Linux and sysadmin and all of it, but Kubernetes is quite new to them also. So that's where certain overlookings and certain mistakes do happen. And if you are running your own data centers and doing this via Ranch or something else, you have to actually do follow a lot of things that I did explain, because my experience is also based on running Rancher based or Kubedium based clusters. But if it's cloud based, there's not much control plane level stuff you have to worry about, but you still have to worry about the microservice level deployments that you do and how you secure them. And some organizations have scenarios where they need to do multi-tenancy within a single Kubernetes cluster. For example, let's say uh, your organization has outsourced certain projects or certain things to some other third-party companies, and you are now providing them infrastructure to run them, which essentially makes it multi-tenant. So in that way, you have to see how to secure clusters, because creating Kubernetes clusters to each and every third-party tenant also could not be realistic, or could be more resource, could be pricey as well. Yeah, so if you follow the proper best practices and do the patches properly, I think you should be good to go. One thing I forgot to mention was always keep your Kubernetes clusters up to date, because every patch there are security vulnerabilities fixed. So don't keep, because this is working right now, don't leave it like that. Continuously keep patching clusters and update them when new updates come. So that's all I have to say. Right. Questions?
So you can unmute your mic and ask questions. We have 10 minutes.
No questions.
Okay.
Yeah, go ahead.
Any questions? So Nilesh, I'm Mustali here now. There are vulnerability and security tools to be implemented in container platform like Neo Vector and all that, which keep on scanning at the pod level or container level up to the layer 7. So I mean that sort of solution will consume more resources in the container platform, and how it goes. I mean, there are many industrial solutions like Aqua, Neo Vector, I think Neo Vector SUSE solution, as I remember, but it consumes a lot of resources, no? As per the layer 7 scanning goes northwest and north south and east west. So how the industry get into this?
Yeah, so I think it's more towards what do you call it, trade-offs, right? The more secure it is, more resources it's gonna take you. I think, and performance also. Because let's say you are using a service mesh. And service mesh gives you a bunch of capabilities, but it's gonna take a lot of resources, and also the performance also takes a dip. So it's all about finding the right balance to your requirements and the tools that do enable it. Like I remember one of my previous companies did use New Vector, and yeah, and then I personally didn't encounter the resource issue, but probably there are, because it's scanning at every layer, right? So yeah, so I think those are the things. So maybe figure out whether that level of scanning is needed for you. If it's needed, there's no way around it. If you don't need that level of scanning and stuff, figure out what level of scanning you need and look for alternatives that do just that. Do it. I mean, there's no magic answer that I can give for that.
Yeah. Thank you, Nilesh. So any other questions before we wind up? I think there is no question in the chat box also. Okay.
Nilesh, I have one quick question. Are there any certification that that are particularly focused on this security aspect, or?
Kubernetes has something called Kubernetes Security Specialist.
Uh-huh.
But if you are more into other security stuff, I think OWSAP, and there are a few certificates that you can do. I think a quick Google search could help us. But yeah. Kubernetes layer, only Kubernetes certified security specialist. That's the exam you have to do.
Right. So that doesn't cover most of this stuff from, I suppose, only.
No. It covers this stuff. It definitely
Alright.
covers this set. But if you are looking for like basically it covers the Kubernetes security side. I don't know whether DevSecOps and all of it there's a certificate. I'm not aware. But Linux system administration and all of that, there are other security exams that you can take, which a Google search could help you. Yeah.
Right. Thanks for the answer and the valuable session. Thanks, Nilesh.
Okay, so let's wind up the session. So very good evening to everyone. So it is with great pleasure that I'm delivering the vote of thanks. Firstly, on behalf of IT and Computer Engineering Sectional Committee, we wish to express our sincere gratitude to IESL President, Secretary, and the staff. So our special thanks to Mr. Nilesh, who has given his precious time to conduct this event. And we are thankful to him for sharing his immense knowledge and technologies on securing the communities with our engineering community. So once again, many thanks to enable this evening to have a successful event. Also, would like to thank our organization team and IT and Computer Engineering Section Committee for helping us to arrange this public lecture. So we are organizing these kind of events to uplift our ISL in all aspects. So finally, I extend my big thanks to all the participants who make this event successful. Thank you. Have a pleasant day. Thank you, Nilesh.
Yeah. Okay, bye.
Thank you. Thank you all. Thank you very much.